Welcome Algebra 1 students to our third quarter benchmark review video number 1. We're using the PDF that's attached to your video post. You can go through and we're going to do the first 14 questions. We're going to do questions numbered 1 through 14 today. And then we'll have a second video with some of the rest of the questions, and then some of them we'll be doing in class because they're calculator-based questions only. So let's jump right in with the first page. All right. Starting with some exponent questions. We start off with a monomials multiplying question. So we're multiplying 4a squared b squared, 4a squared b squared times a cubed b to the 6th. Remember what's happening here. We're just multiplying. Okay, don't make it more complicated than it is, but use your commutative property and rearrange. So I have a 4, I have a squared times a cubed to multiply, and then I have b squared times b to the 6th to multiply. And that's what we're going to be multiplying. So we're adding our exponents because that's what we learned for power of a power, is add our exponents together. So we have 4a to the 5th, b to the 8th. 4a to the 5th, b to the 8th, which puts us at which answer? B. So that's not complicated at all. Let's move on. Now we have power of a quotient. Power of a quotient. So I have x squared over y to the 4th, and it's being raised to the 3rd power. Now, don't automatically look at that fraction and say, oh, I got to flip that over. No, you don't. There's no negative exponent. Look at the exponent there. It's a positive 3. All we're doing here is raising each of these to the 3rd power. So, hopefully what we need to remember here is that when it's power of a power, we don't add, we multiply. So we should have x to the 6th on the top, y to the 12th on the bottom. No reason to flip it. J is the correct answer. What are the what would the expression be if they wanted us to flip it over? Instead of x to the 2nd over y to the 4th, the quantity cubed, it would be to the negative 3rd. That would give me h as an answer, where it's flipped over. Okay. So far, nothing super complicated. All right, next one is another fraction to simplify. I chose an extra one of these because we seem to have more trouble with simplifying the fractions than most of the multiplying ones. Remember to start with the numerical part of the expression. 8 over 4 is still the fraction 8 over 4. Okay, that's a 2. So when I simplify that, I have 2. Now I'm going to keep my base, subtract my exponents. Keep my base, subtract my exponents. Okay, we're listening, by the way, I'm sorry, I forgot to tell you, to Paul Simon. I think I might have done Paul Simon for the last one, but it's more Paul Simon. I don't think it's very much that's duplicated. I just really like Paul Simon. 2a, 6 minus 3 is 3, and 7 minus 1 is 6. So 2a cubed b to the 6th. 2a cubed b to the 6th puts us at answer choice A. Okay, so far this is not super difficult. Let's keep going. All right. We've got some two-dimensional models of polynomials. So we used algebra blocks in class, and we really only used the positives. So let's look at our key here that they gave us, because it's something distinctive I want you to notice. And I absolutely think this is written to confuse you. Remember that I don't write the questions on the benchmark. I just got to teach it. So don't kill the messenger. All right, look at the key. So here's our key right here. This gray square is a 1. The white square is a negative 1. Well, isn't that counterintuitive? Wouldn't we expect it to be the other way around? Well, look all the way through the key. The shaded rectangle is an x. The white rectangle is a negative x. Now, normally they do the shaded one, the negative, only because we think of the two colors. You know, it's the one that we're used to being the shaded one's the negative. That's not what they did here. So always look at your key very carefully. So we are multiplying. I can tell it's multiplying because I have a horizontal and a vertical axis here. And I know what one of the products is. It's 3x, x, 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 and then that's 2. So it's 3x plus 2. Now, what we learned with an array here is that we multiply. We put one on the horizontal, one on the vertical. So that's what we're finding. And we've got to figure out what goes here. What goes here? So in order to take x and multiply it by something else over here and get this, which is x squared, and it's positive x squared, what do we multiply x by to get x squared? Well, we multiply it by x. But I'm not going to write an x there because that doesn't make any sense. I'm going to draw an x there. Okay, and for kicks and giggles, I'll go ahead and just kind of color it in blue. All right, so that's an x. Well, what has to be here? Well, we've got a positive 2 here, multiplying by whatever's here, and it's yielding this, which, look at your answer key carefully, this is -2. So what would I multiply +2 by from over here to get a -2? Yes, that's right, I heard it from somebody out there in TV land or internet land, -1. So this is an x, this is a -1. X minus 1, that's our factor. So it's a little bit tougher because it's something new. Now remember, a benchmark asks you to apply all your knowledge. You are not going to be expected to, or I am not expected to show you every single type of problem that could occur to them to put on the benchmark. Sometimes you're applying knowledge and you already know the knowledge, you have to figure out how it applies in the circumstance. So remember, no, I'm not going to be able to expose you to everything. That's just not physically possible. I'm only one person. I'm not capable of finding every possibility they could come up with. All right. This one's easier, but the key is still the same. Always double check your key. You never know when they'll switch it on you. Shaded one x, open one -x, shaded square x squared, open square -x squared, shaded little unit 1, unshaded unit -1. Add it up. What do we got? Well, we got an x squared, another x squared, an x, and a -1. So 2x squareds, 2 x's, and a -1. There it is. 2x squared plus 2x minus 1. Keep on trucking. Okay, number 6. Now we're doing some subtracting of polynomials. Now I don't think I taught this as coherently as I should have in the first place, so I'm going to rewrite the problem the way we've been doing since we've been reviewing this in class. And I've done this with some of you working on your test corrections. Rewrite. So I'm keeping the first one, changing it to addition, switching the sign of everything in that second set of parentheses. So now that's -4x and minus 3xy and a +4. Now I've got to find my like terms. 3x squared does not have a like term. -4x does not have a like term. 2xy minus 3xy, that one does. 2 minus 3 is -1xy. -6 plus 4 is -2. So when we subtract, remember that we're subtracting every term. If I can do it accurately all the time without rewriting it, go for it. If not, then rewrite it. Take the time. You can find lots of good practice for this on Khan Academy. Next one is multiplying two binomials. Let's multiply them out with FOIL. First, outer, inner, last. First, 4y times 1, 4y. Outer, oh, what did I just do? I messed that up. Let's try that again. First, try that again, Mr. Comp. 4y times 3y, 12y squared. Outer is plus 4y. Inner, remember inner, we mean the inside one for both of them. -2 times 3y is -6y. And then last, -2 times +1. So the key when you're multiplying these binomials is to recognize the pattern and to be very careful of the signs. If you rush through it and you make a sign mistake, you're going to find the wrong answer because they're multiple choice most of the time. Okay? Now, number 8, 9, and then when we get to it, 10 should actually look familiar to some classes. Unfortunately, not to all of them because we're just plain behind, especially in first block, because of all the testing time that we've taken. This looks different. Don't panic. They're asking us to divide off this common factor. So what this is saying is, if I was to factor out a 2x, what would be left in there? That's our answer for this problem. So if I'm dividing each of these by 2x, if I factor out the 2x, what would be inside the parentheses? Well, for this one, it starts with 3x cubed divided by 2x is going to leave me 3x squared. 6 divided by 2, 3. X cubed divided by x, x squared. 4x squared divided by 2x. 4 divided by 2, 2. X squared divided off 1x leaves an x. 2x divided by 2x is 1. But if I'm dividing, the 2x is gone. The divisor doesn't stay in the answer if I'm dividing. If I had just been given the insides of this right here, just been given this and said factor out the GCF, we'd leave the 2x. But we're dividing. And we haven't talked about this division yet because it's kind of new in our curriculum, and all we're really doing is factoring out the GCF there, and it's just what's left inside. This one, also not complicated, I promise. You can factor this trinomial, and that's your first goal. One of the factors in every one of these that they give you, this bottom factor, it's going to match. So I've actually got half my factoring already done for me. Okay, I've already got half my factoring done for me right there. What I have is I know that if this is p plus 8, the pattern they're trying to get us to notice here is that we can cancel common factors. So when I have a product of negative 32 and a sum of 4, I have a product of negative 32, and a sum of 4. I have p plus 8, positive 8, and p minus 4, negative 4. 8 times negative 4 is negative 32. 8 plus negative 4 is indeed 4. Now what they're trying to get us to see here, and again we cover this in some classes, not in all of them, is that the common factor on the top and the bottom cancels. We've done this before. If I have 3a squared b cubed over 2ab, the common factor is that b cancels one of those. And same thing, or a in that case, cancels one of those. We're canceling off the common factor, and all that's going to be left here is the other factor, p minus 4. So it's really just factoring and canceling. It's not really division. Okay, let's try the next one. So yet another way to show polynomial division. And again, we're factoring out the 5x and leaving in the parentheses what the answer would be. And then remember, we're going to drop the 5x, and that's going to be our answer right here. So negative 10x to the 6th divided by 5x. I might benefit from writing that one down. Well, negative 10 divided by 5 is negative 2. So I got that part. And then x to the 6th, if I take off one of the x's, leaves me x to the 5th. Next one is negative 5x to the 5th over 5x. Well, negative 5 divided by 5, that's negative 1. Oh, sorry. Hit the bottom of the screen by accident there. Negative 5 divided by 5, that's negative 1. X to the 5th, divide off an x, leaves x to the 4th. And I left the 1 there for now. We'll drop it in a minute. Last one is 15x squared over 5x. Well, 15 divided by 5 is positive 3. X squared divided by x is just an x. So my answer is negative 2x to the 5th power minus x to the 4th plus 3x, and there it is. So division is really just factoring and then dropping the divisor from the answer. Now we've got 4 questions left, and they're all factoring questions. We've been working on this in class quite a bit, so hopefully you're feeling more comfortable. What are the little red flags, little red wavy flags that should be popping up in our minds? Okay, it kind of looks like a flag. Be nice to me. That should be popping up in our minds when we read the question for number 11. Well, 4 and 25, they have something in common. They're both perfect squares. And I noticed that this is a binomial. A binomial, not a trinomial. And I noticed that it's a difference. So it must be a difference of squares. And how to factor that? Well, we know it's going to be 2 binomials. The square root of 4x squared is 2x. So that's the first term in each one. The square root of 25 is 5. That's the second term in each one. One's a sum, one's a difference. Done with the problem. Next, number 12. What is a factor of 2x squared minus 9x plus 7? Now, this is kind of a dirty little trick that they pull on us. You have to be able to factor the whole thing. You cannot just kind of factor it. You should not be guessing. So we do have to factor this to figure this answer out. And this is the type of problem where we're going to have to look at A, C, and B. What are A, C, and B for this problem? Well, AC is 2 times 7. And for those of you having trouble remembering what that means, remember A is the coefficient of x squared, or the quadratic term. B is the coefficient of x, or the linear term. And finally, C is the constant over here. So, 2 times 7, 14. We want factors of 14 that add up to negative 9, negative 7, and negative 2. You're going to take your polynomial, you're going to keep the first term, you're going to split up that middle term into 2 parts, like I just did, and keep the last term. Now you're going to factor by grouping, by looking at the individual pairs. GCF of the first pair is just x, because 2 does not go into 7, and 7 does not go into 2. Now that I factored out that GCF, I'm going to leave myself a little space right here, and I'm going to put down the 2x minus 7, because I know that for this to work, that has to be the duplicate factor. Now, in this type of problem, I guess I'm kind of done, but let's finish it anyway, just in case we weren't finished. So, we have minus 2x plus 7 up here, and we want to know what to factor out of it to leave a positive 2x minus 7. Well, to get a negative to turn into a positive, but not change the number, we factor out a negative 1. The duplicate, that's one of them. Everything you see on the outside, that's the other. All right. Looking at my answer choices, x plus 1 is a choice. Wasn't in my answer. 2x plus 7 is a choice. And x minus 7 is it's 2x minus 7 because that's what you see right over here. Awesome. Next one. Greatest common factor. Hopefully you saw it. There's a greatest common factor there. It's 9. Let's divide off that 9. That leaves me 2x squared minus x minus 1. So now I'm factoring from here. Now, what is a good trick for a multiple choice question that asks you to factor? What could I do instead of actually doing the factoring? Now, of course, I want you to do the factoring, and I need you to know how to factor. But what if you didn't, what if you panicked, or what if you wanted another method? Or if you tried to factor and couldn't do it? You can always go through and multiply out these choices until you get the answer, the original problem we started with. Let's factor it, though, anyway. So, again, A, C, and B. Switch to the pen tool. A equals 2, C equals negative 1, so AC is negative 2, and B is negative 1. Remember that the 9 out front is not leaving, but I'm going to drop it for the purposes of factoring just this. We're going to keep the first term. We're going to split apart the middle term. What were my factors of negative 2 that add to negative 1? They were negative 2 and positive 1. So there we have it. We split up the middle term. Factor by grouping. Common factor in each term. This one has 2x, leaving x minus 1. And the other one's already x minus 1, which means we're factoring out a positive 1. 2x plus 1, x minus 1. So we've got the 9 from the beginning. Don't want to forget it. 2x plus 1, x minus 1. It's the first choice, A. 14 is another one like 12, and I don't want you to be daunted, scared, freaked out by this y squared over here. All that's happening in this is that the second term in each binomial has a y in it. Let's just for a second, let's think about this. Let's think about it just from a different perspective, just for a minute. Different problem altogether. Okay, so let's say 2x plus 3y times 3x plus 2y. I'm gonna multiply that out. Okay, what happens to the writing? Okay, good. It still sticks to it. Just checking. All right. If I FOIL that, I'm going to get 6x squared. And then the middle terms are going to be plus 4xy plus 9xy. And then you're going to have plus 6y squared. And you see how that y is only there because it was in that second term for each one. And that's what we're going to have on this particular problem. So zooming back in to continue. First, I see a GCF. Let's take it out. It's 10, leaving x squared plus 4xy plus 3y squared. This has not changed the process we're doing. We'll still keep the 10 in our eventual answer. We're going to drop it for now so it's not in our way. And I still want factors of C, which is still 3, that add up to B, which is still 4. What are the factors of 3 that add up to 4? There's only 2 factors of 3, guys. 3 and 1. Now, I know this is x and x in order to give me x squared. But in order to get that y in there, it's going to be plus 1y and plus 3y. So we just tack the y on to that second term in each one. So x plus y, x plus 3y, and we can see G is our correct answer. The rest of them did not fit. So that's 14 questions to the tune of Paul Simon. We will keep working on this. Keep the PDF either on your iPad or come and get a paper copy from me if that's something that you want. I will have them in class so that you can come and get them. Thank you for watching. I will see you guys in class.